It's time for another teardown, This is the power supply I've had on my bench here at RC Model Reviews for quite some time. It's a switched mode power supply, 30 volts, 5 amps DC, which means 150 watts. It has a voltage control and a current limiting control, but the current limiting control has never actually worked, which is a bit of a pain in the backside. So I'm going to tear it down today, have a quick look inside and see if I can spot why that is. It'll be a good opportunity to see what's inside a pretty low cost power supply like this. I think it was 60 bucks, so don't expect too much. Let's get into it. I've taken out the 4 screws that hold the top case on, and hopefully this should just slide off. Here we go. Ta-da! Ooh, first thing I don't like about it is look at the angle that board's on. It's pretty dodgy. Let's have a look inside. There's a lot of stuff in here. Time for some close looking. Got to say, it doesn't look good. The board is really only mounted. Oh, how have they mounted it? It's got one screw at the bottom in here. You can see a screw down there on a bracket. Hopefully that will show up in the camera. There's a bracket down there with a screw. Probably see it on the other side. Oh no, it's got an earth strap on it as well. Look at this. Look at this bodgy wiring. Power resistors. Whoa. Yeah, not so impressed yet. Anyway, we've got one screw down there and then one over here, and then it's stopped from flapping around simply because it's connected to the front panel here. So there's nothing up the top here stopping this from waving around in the breeze. That's a bit how you're going. Never mind, let's have a bit of a look and see if we can work out what's going on in here. Well, first of all, our mains is coming in through this, maybe on the other side we'll see better. Mains through an IEC connector, that's one of those. So you can put your kettle cord, your jug cord in there. Earth goes over, The earth wiring is barely satisfactory. It goes to 2 points on the board, I don't know why. I guess it saved them putting some copper on the board. Never mind. So the mains wiring, where does the rest of the mains wiring go? It actually goes, the rest of the mains wiring, as you can see, hopefully. Red wire phase goes down here onto the circuit board in there. Are there any, there's no, oh here we go. So this is our high voltage portion here. Nice that they've got some cutouts on the circuit board. That just stops any tracking across the circuit board. So that's not so bad. They've isolated the high voltage area from the low voltage area, which is, when I say not too bad, it should be standard practice. There shouldn't ever be anything that doesn't have that. Let's see what we've got on the other side. So basically what's going to happen here is our mains voltage coming in. There's a little bit of filtering in here. There's a choke there. Capacitors, MOVs I think down there. MOVs are just things that are designed to protect the circuitry from spikes in voltage. It's rectified and it goes into these capacitors here, which are what brand? Ooh, are they a good brand? What have we got here? Nichicon caps. Ooh, so actually I'm surprised. Either that or they're a knockoff of Nichicon caps, I don't know. Got a couple of devices here. These are probably the switches in there, the switching transistors that will drive this transformer at a high frequency. And this is why switching power supplies are smaller and lighter. Instead of using the mains frequency, which is 50 or 60 hertz, depending on the country you live in, these things use a much higher frequency. And as you go up in frequency, you can use much smaller transformers. So this transformer at whatever frequency they're running at probably hundreds of kilohertz, is the equivalent of a great big huge 150 watt transformer at 50 hertz. So it's a really cool way to get lightweight small power supplies, and that's these days they're used in everything. Even our switch mode BECs have high frequency, not transformers, but they have an inductor which works very well at high frequency. So we've got another large inductor here, which I'm not too sure, that may be some ripple control on the output, I don't know. There's a regulator or switching device here, and these are all those. Let's have a look at those. Ooh, that's pretty bodge on the back here. This soldering is, what have we got here? Just a minute. Is that I'll have a close look at this under my microscope or my macro lens and see what it looks like. But it's looking pretty bodgy from here. I haven't got my glasses on. It's easy to see the screen without them, but this is looking pretty bodgy. And this soldering up here is decidedly slack. In fact, I should be careful in here because this was plugged in earlier today, and these capacitors, these big mains capacitors, can hold a pretty heavy amount of current or a large amount of voltage, and they can dump it through your fingers even though it's unplugged. So something to be aware of. If you're going to pull stuff down, you've got to know what you're doing, because even when it's been unplugged for quite a while, you can still get a really nasty shock. You could even kill yourself by poking around inside one of these. So I'm being a little bit careful here for obvious reasons. These are the pots that they've got here. They are multi-turn pots, which is good, but as I say, the current one doesn't do a damn thing. So I'm thinking maybe it's not soldered on properly or something, because, oh, again, pretty bodged soldering in there. I'm not really happy with that. But let's have a look at the rest of it, assuming I can work out what's going on. We've got quite a bit of discrete circuitry in here, actually, for something as simple as a switch mode power supply with a variable output. I'm amazed at how much stuff they've put in here. When you see a lot of components in a device that should be essentially quite simple, generally it means either it's an old design or the people who designed it were using the cheapest possible parts. And sometimes it's a lot cheaper to buy the cheap parts and use lots of them than to buy the expensive parts and use a few of them. So that could be the case here. I'm also wondering about all these trim pots, these little blue things, they're trimmer pots. Yeah, do you really need that many? If you've got a precision voltage source, you shouldn't need that many. This is, I don't know. Yeah, I mean, I paid $60 for it. I mean, what do I expect? This is not an Agilent or a, what do they call themselves now? Can't remember the new name for them. It's not a high quality lab standard power supply. It's a cheap and cheerful one, although at the moment, not that cheerful by the look of it. So the soldering quality of the flow soldering is pretty good. The reflow soldering looks pretty good, but the manual soldering is a bit diabolical. Oh, it looks like we've got a current shunt in here. This little loop of wire here, if we can see that under there, hopefully. That little loop of copper wire, that's a resistor. It's a very, very low value resistor, but it's used to measure the current. And it should be used by the current limiting to tell us what current is going through the device so we can adjust the maximum current. But in this one, it doesn't work. Oh, never mind. Got plenty of capacitors in here. These look like El Bajito capacitors. I don't think they're any good brand. They're a surface mount, so it's a bit hard to tell sometimes. And what do we got? This is the, oh no, look, this is the power switch up here. This is a mechanical switch, not a soft switch. And the mains wiring comes, well, I guess it's not too bad. It's got heat shrink and things, but it's running right over the top of the logic circuitry. I would have rather have seen something a little more elegant. And also it just solders into the board down here. I'm not happy where mains wiring solders straight onto a PC board without any form of support, because that can fray and break. Not too happy with that. There's the bridge rectifier that turns the mains voltage into DC, and it's just stuck up here on these. It's designed to have a heatsink mount. You can see it's got a bolt hole through it, so it's designed to be heat sunk. It's not heat sunk. Maybe they're running it well within its capabilities, but not having any form of mechanical support is not good, because, you know, even over time vibration can fatigue those legs. That's why they have a hole, because they're heavy and you need to bolt them to something. Even if it's not just for heat sinking, it's for mechanical support. So bit budget. There goes my phone. Yes, so there's not a lot really to tell. Another choke over there. These inductors are not supported other than by the wires. There's no celastic around them or no glue. Same with these caps. Really good quality power supplies. You find a lot of white celastic around the capacitors and other items to give them physical support. Not much around here. Now, in here, we can see a whole lot of white crap down in there. I'm hoping that is actually for a thermal sensor. Hopefully they've got overheat protection. There'll be a little thermal device in there that will be able to detect when this thing gets too hot and shut it down so it doesn't blow up. Or it could be that they just had a bad day with the heatsink gun and squirted it in there by mistake instead of going onto the actual heat sinks. Who knows? Who really knows? Oh, the metalwork's nice. I like the metalwork. Yeah, but that's really inconsequential. Okay, I'm going to take a closer look and see what else I can find in this thing. Okay, I think I've discovered why the current limiting knob on this doesn't work. It's diabolical. If you notice, because this board is on an angle here, if we look down in there where these potentiometers are, these multi-turn pots, they come straight up, but the board's angled up, which means that although the rear, bit hard to see, isn't it? Although the rear connections on those pots come through the board and can be soldered, the front ones don't. And this one, you can see that it hasn't even come through. And here's the two that are soldered. This one, it hasn't actually come up to the board, so it's not connected. This one it has, just barely, but this one for some reason hasn't come through the board. The angle's too great, so, oh man, talk about cheap. It's diabolical. I'm going to try and resolder this so that it makes contact with the multi-turn pot that is this one here, which is fitted to this really, really angled board, which is really most of the problem. It's unbelievable. Who would build something like this? This is terrible. Oh, okay, see what I can do. Oh man, the more I look at this thing, the more, the worse it gets. I mean, look down here. See the little solder web? Someone's just soldered that, and look, it's just got a little piece of solder here. There we go. Now that sort of thing, when it gets loose inside circuitry like this, can cause mayhem. Shorts out, blows shit up. Oh, yep. I don't know what's going on here, but whoever made this wasn't a very good person at what they do. And here's another close-up of the missing thing. It's actually, you can see it down there. This one here just barely makes it. It's just flush. This one for some reason hasn't come through at all. So, and look, there's still this crap all around here. The manual soldering has been really bad. And something else I've got to show you. This is incredible. I mentioned that the top of this board wasn't retained except by connection to this board. Well, it's actually not a connection to this board. The only thing stopping this board from wobbling are these two LEDs, which are soldered to the board there. Apart from that, it's only screwed in at the base. The entire top is free to move, and it's just sort of touching the board there. It's not actually mounted on it. It's no physical connection there. It's just touching. So these LEDs are the things that stop the board from flapping in the breeze. Unbelievable. My goodness. Actually, I'm picking that this had a fault and they've tried to fix it. If we look at this transistor down here, the one that had the little spike of solder on it, you can see it's actually been melted. There's other solder on the top here. I think someone's come in here and tried to resolder that joint or mess around here, which is why we had that solder spike. You can see the plastic has got solder on it as well. That doesn't come from the reflow process because these bits are actually put on after the solder paste is put on, so the reflow won't climb up onto the top of it. Someone's had a go at it to try and fix it, and I guess, and look at the quality or the lack thereof of the soldering. Got the big ball of solder there, and there's rosin flux here. Like, you don't usually get this flux residue with reflow soldering, but there's some here. So someone's actually put that resistor in there as well. It's like, and this is all in the current sense circuitry. So like somebody has realized this thing is faulty and they've had a go at fixing it, and they've failed because it still doesn't work. The current sense still doesn't work. So, oh, yeah, that's maybe why it was so cheap on eBay, eh? Who knows? So I'd be a bit careful. Maybe someone's selling seconds, because it's definitely been replaced, that resistor and that transistor, well, unless they're really bodgy and they damaged that while they were trying to solder this. Yes, something is not quite right with this thing. Someone's had a go at it. And it was brand new from eBay, but you know what eBay's like. People buy the ones that don't work, probably have a try fixing them up and then flick them off. Terrible. Oh, too bad I already gave them positive feedback because I hadn't tried the current limiting out. This may actually turn out to be a good fault finding project. If anyone's interested, I could use this. I might trace through the circuitry, see if we can fix the current limiting, see what's wrong, because obviously someone's had a go but they couldn't do it. Why don't we have a go, see if we can fix it? If you're interested in seeing how I do that, then leave a comment in this video and I'll do the fault finding process online, let you all know what I come up with. But yeah, let's have another bit of a look around. Well, what do we got here? We've got it's hard to read these things because I don't have my thing on. I shall look up these chip numbers, and if it's necessary I'll post the data sheet in. This is a TL084C. I don't know what that is, but obviously it is doing some comparator stuff. And what have we got here? I don't know what that is actually. SG3525AP. Do not know what that is. I don't have an internet connection at the workshop here, so that makes life a bit hard. And there goes my phone again. Well, there you go. Resoldering that multi-turn pot didn't fix anything because I think the problem lies a bit deeper. As you can see, someone's had a play around, someone's tried to fix it, they couldn't fix it. And I think that terminal on that pot actually isn't used, so it's not as bad as it looked. It's used as a variable resistor, not as a, well, part of a variable part of a voltage divider rather than as a pot. I don't know why, but that's just what they seem to be doing. So, yep, I will put this, I can still use it, just doesn't current limit. So I'll use it in the meantime, and when I get the time, probably after I've fixed that welder I teared down a while ago, I'll have a go at fixing this to get the current limiting working. And if you want to see what a linear power supply looks like, I've got this one up here. Where is it? Up there. So maybe I can pull that apart and compare it to the switch mode one. You'll notice that's actually really quite a big bulky thing. Interestingly enough, the current limiting on that doesn't work either. Why do I get all the crap? I don't know. Maybe because I don't have much money and I buy the cheap stuff. Anyway, so there you go. That was a quick teardown, and look at a really, really bad, see the angle of the board, really bad piece of kit. But hey, having said that, it does work. It gives me variable voltage and it delivers, you know, pretty much the power level. It has, it does do up to 30 volts and it does do almost 5 amps. So yeah, I'm not going to complain too much. It seems to work. So for 60 bucks, I couldn't have bought one for that. So I'm still happy with the purchase, but I'm sure I can make it work properly. Thanks for watching. Catch you later on the, which channel am I on? On XJet, of course. Bye for now.